hope you are all awake for one last presentation. I'm going to introduce the next generation file format OME-Zarr for those of you who might not have heard of it yet. And we'll also mention a bit of the tooling around it. So OME-Zarr is a next generation file format, which are generally used term for file formats that are cloud optimized. They offer faster access to large multi-dimensional data sets, especially when they are stored remotely. And OME-Zarr is an implementation of next generation file format, and it has basically two main features that correspond to this improved, faster access to the data sets. So one of them is the chunk storage. So an image array is split up along its dimensions into smaller tiles, and each tile is basically saved to a different path, forming a nested folder structure. So a single OME-Zarr a single Zarr dataset is actually a nested folder structure. And the other feature of OME-Zarr is that it has native support for multiple resolution layers, so-called resolution pyramid. So why do we need chunking? The short answer is that chunking allows for direct on-demand loading of a specific subset of data. So if you imagine that you have a three-dimensional image saved in a so-called monolithic format, such as TIFF, and you want to visualize this kind of oblique slice, normally the viewer needs to just read all of these planes in order to just make it possible to visualize this oblique slice. Also, what you need is actually single lines of pixels from each plane. It's not possible to do that because the planes are monolithic, so you cannot just get subsets of data from that. But Zarr makes it possible to arbitrarily chunk your data set. For example, you can have such cubes, and you can just directly only load these cubes that correspond to the oblique slice that you are interested in. And when you move the data sets, like do rotations, then the viewer will automatically adjust and get those only the chunks that are demanded. So that's the advantage of chunking. There are actually multiple other benefits, like it's possible to write chunks lazily to for example, a remote storage in parallel. And these are all important features for like working with big data in cloud. And the second feature, like resolution pyramids, this is also important to really like access very large data sets, especially when you want to visualize them. For example, if you have like terabyte scale data sets, the viewer will automatically load the data sets that one of the lower resolution layers in the pyramid, because only that one would fit into memory. So it will directly find out one of the lower resolution layers and it will load it into memory if you want to really see the entire data set in the frame. But very often you don't, and you want to see a specific subset in greater detail, then you zoom into a specific subset, and then the viewer will automatically adjust to the higher resolution layers and only load those chunks corresponding to that subset. But in both cases, you won't overload the memory because viewer will adjust and find only the parts of will make sure that the amount of data that is loaded will be within the memory limits. So it is then a trade-off between either seeing the entire image but at low resolution, or getting greater detail but only at a certain subset of the image. And you can learn more about OME-Zarr in these publications. So this is basically a benchmarking study comparing the access performance of OME-Zarr to some other file formats. And here you can find out more about the existing tools such as converters, viewers, and other sorts of tools. And I will also briefly mention a couple of the viewers. This is important because now there's actually already a mature viewer ecosystem, also for different platforms, such as for PG and for Napari, but also independently of these, there are a lot of web-based viewers. They're also nice because they require no tool installation, so you can just use your web browser to visualize OME-Zarr. So I just want to detail two of these viewers. One of the latest developments is this M5 reader, and it is not only a viewer, but it allows you basically to carry out image processing with OME-Zarr datasets. It can read a Zarr dataset into PG environment and represent it as just standard PG image on which you can perform image processing using PG's various image processing tools, and then you can save it as OME-Zarr. But also it has an integration with Big Data Viewer interface, so you can just open your very large OME-Zarr datasets in Big Data Viewer interface. So I have a video for this actually. So if you imagine that you have a bunch of OME-Zarr datasets here, so each OME-Zarr dataset is basically a multi-resolution pyramid having 9 different resolution layers. And these basically are different channels corresponding to same image, but each channel is basically saved as different OME-Zarr. Then, for example, you want to open and visualize all of these at the same time. And for this, the requirement is that you need to have the latest version of this N5 reader, because these features, most of these features just came with this latest version. And once you have that, then in the Big Data Viewer menu, you will find this HDF5 N5 Zarr OME-Zarr Viewer. You click that, and then you can browse to the location of these OME-Zarr datasets. So you basically go here and then click open. When you say click open, then it discovers the whatever files in that folder. So in this case, it already tells us that each of these is basically a multi-scale, which means resolution pyramid. Then you can basically open this. You can select any of those that you want to visualize. In this case, I simply select all of them and click OK. Then they open in Big Data Viewer. And if you know already, if you are familiar with Big Data Viewer, then you can just use Big Data Viewer as you normally use it with other sorts of data. So you can basically alternate between different Zarr data sets that were open, or you can do things like brightness contrast adjustments. Yeah, so this is basically how N5 Viewer works. There are other Fiji tools that you can also use with OME-Zarr. And for example, one of them is Mobi. It is also quite popular. And it's capable of also opening very large data sets. And also we have Napari tools. Napari OME-Zarr also can do, for example, visualization of multiple data sets in the same frame. So that's it with Big Data, with N5 Viewer. We can continue. And I also wanted to just show one example of web-based visualization. And this is actually very simple. As I said, there is no installation required. All you have to do is just go to this link, and it already opens with an example data set. So this is not ours. This is already a data set that exists. We simply replace it in the browser, the path, the URL, with the URL that we want. So our own image. I simply paste it here. So this is the location of that data set. And then it opens. That's everything that's needed. So this is only one of the existing web-based viewers. There are many others. Some of them also support 3D rendering. And some of them support, for example, high contrast screening imaging. But yeah, there are many others. And you can, importantly, you can also share a view. So you can just get a view and share it with your colleague who exactly just can visualize it the same way as you do. And what we are doing to support OME-Zarr, we focus more on other aspects such as conversion of images to OME-Zarr at high scale, so high throughput, and processing of OME-Zarr data sets. And you can find our repositories here, and some of them also are Anaconda installable from our channel. So first, the conversion. We have a command line tool called BatchConvert. It uses Nextflow to parallelize conversion of image data via bioformats row. So it parallelizes basically bioformats row to convert either into OME-TIFF or OME-Zarr, and has a few additional features. So it supports local or remote input-output options. It readily runs on Slurm managed clusters. You only need to specify one command line parameter to run it on Slurm to parallelize over the cluster. And there's unary or aggregative conversion options and file selection, complex file selection options like pattern matching, wildcards, or provide a CSV file to indicate file locations. So this is basically an illustration. You can have your input data in an S3 bucket or your local storage. Also, your output data can go to an S3 bucket or local storage. And importantly, you can also submit data to Bioimage archive directly. So the conversion is then coupled to submission to Bioimage archive. You can do this by specifying either in the configuration or on the command line. This is an example just to illustrate what I mean. Unary or aggregative conversion. The unary conversion, you simply parallelize the conversion or all datasets in such a way that each input becomes one output OME-Zarr dataset. In case of aggregative conversion, basically the tool recognizes which files belong to the same image and it merges them together. So the output of this, for example, a single OME-Zarr series. So you can do these kind of things as long as the file names basically are indicative, like descriptive enough. Then we also have another conversion tool. So this is actually bioformats row becoming a Galaxy tool. So we basically support this Galaxy tool environment. This Galaxy basically is a platform for many tools that run in the cloud. So it runs completely in the cloud, and the user has the option to link multiple tools to create their own custom workflows on a web-based graphical user interface. And what we did is we made bioformats row a Galaxy tool, so it can be also incorporated into a workflow. And here I show it briefly. So what you have at the beginning is, so you have some data, you have to upload them to this web environment. So I have two images, two TIFF files here, and the tools basically are shown here. So if you go to this imaging.usegalaxy.eu, you already have a list of tools here. And you can, as I said, like user can either use these tools individually or can create a workflow from them. And our tool is basically here. So it is named Convert to OME-Zarr with Bioformats. You click there, and then, yeah, you have this interface. And as I said, we have the images here. We can choose which image to work with. I just chose this one. Then you can also specify an output name. Then you can go here to parameterize the conversion process. So you can choose, for example, the chunk dimensions or the compression method or whatever. And yeah, then you only just need to click Run Tool. Then it creates the output here. So it takes a while. And yeah, you can use all of the tools here in the same way. And when you want to create a workflow, you come here, workflow, click on the workflow, and then it gives you a list of workflows. Importantly, you can actually save your workflows, or you can import a workflow, create a new workflow, and you can then export an existing workflow, for example, after editing, and share it with your colleague who can then run the workflow with the exactly same parameters that you already specified and optimized, for example. And basically, you can use all of these tools. You just need to click them and parameterize them. That's basically about the Galaxy and the OME-Zarr conversion tool at the Galaxy. One important point is that, unfortunately, at the moment, the Galaxy doesn't support Zarr data type. This means that you can only use the OME-Zarr conversion as the last step at the moment, because otherwise the output of this tool won't be recognized by other tools at the Galaxy. That's one important point, but currently there are efforts to make Zarr a data type at Galaxy. Then it will be possible to also use this at any other position in your workflow. And this is it with conversion. And lastly, we also developed a small library for processing of images in the OME-Zarr format. And this library provides an OME-Zarr object in Python environment, and it wraps a number of functions and methods to lazily process OME-Zarr data. This is currently a work in progress, and but still you can do some simple work tasks with it. So the wrappers are from many functions, from NumPy, SciPy, or scikit-image at the moment, but other libraries will also be included in the future. And it's useful because it automatically handles the voxel and multiscales metadata. So whatever you do with NumPy on a normal NumPy array, it performs this on OME-Zarr data, taking care of the multiscales and voxel metadata. So you can also include, for example, a dimension with string rather than a number, an integer, as in the case with NumPy. And it also parallel writes chunks and automatically handles chunk borders. So it works chunk by chunk, it processes chunk by chunk and parallel writes those chunks, handling the chunk borders. Here is a very simple example what you can do with this library. So this is the pyramid object. It is used to represent OME-Zarr in Python environment, and the functions you can apply using the operations class. So this is how you read the data. The pyramid object is here, and you can access some metadata like resolution paths, shows the names of the resolution paths, and it shows the axis order here. You can get the shape for the top resolution layer. Then you can get the operations class. You can use it, for example, to carry out median filter on this pyramid object. You just need to specify the output storage here. And this object is another pyramid, as another instance of the pyramid class. And this is its storage, its directory storage. Then you can take this and use this as input, for example, for maximum projection. And it uses the NumPy's max function. And as I said, you can use a string as axis. So we project along Z here. And we specify that the output goes here. And then this is basically another pyramid object. As you see, you can also now access the metadata from that, and it shows you that the Z dimension is 1 because it is a maximum projection. This is a simple piece of work that you can already do with this library, but in general, it is a work in progress, and it's definitely far from being stable at this stage. So that's everything. Thank you very much for listening.